It's okay. This morning, we'll be looking at integration. And we know very well that we have done some integrations, two of us, if I'm not mistaken. Integration. And we said I should do revision on first principle. It's okay. Assuming you are asked to let me just solve one example on first principle. Only one example. If y equals to 12 squared, differentiate the y over x first principle. Okay, I'm going to solve only this example. Then, please, you apply it anywhere you find yourself. Whenever you are asked to use first principle. Let's write solution. We know that our function y is equal to 2x raised to power 2, right? So ordinarily, if we are to differentiate this function, what are you supposed to have? 4x, right?
Yes, sir.
It means ordinarily our dy all over dx is equal to what? 4x, right?
Yes, sir.
But here we are asked to differentiate from first principle. So this implies that our first principle formula is y plus dy is equals to f of x plus dx. Amen?
Amen.
Okay? So far, so good. As long as you know this formula, I don't think it's difficult. And you are going to use binomial theory if you still recall binomial theory. Yeah. This is the function 2x squared, right? So let us compare this idiot and this one together. I just want to open your eyes how to use first principle. We know that here we have f of x plus what? Yes, right? Then here we have 2x squared. We have to equate it, compare it with this. It means your f here is what? 2. Thank you. Then this your x is this. But x is what? Squared. Is that clear? So for this reason, you are going to write this in this form. Y plus dx is equal to what? 2 open bracket x plus dx all in one. So supposing here is 3. It will be raised to power what? 3. Thank you. Are you following? Okay. Then, assuming, let's look at it here. Assuming here, y has been given as 2x squared plus 1. Amen? Amen. It means this is a constant. True or false? True. So it means what you are going to write is y plus dy is equal to 2 open bracket x plus dx all in square plus what? 1. Amen? Amen. But supposing here is x. Supposing here is x. We are not going to write it this way because this is a function. True or false? True. So since your x is raised to power 1, you just we are going to write this. This is your x. So you are going to write x plus what? Yes. Do you understand? Okay. So let's go ahead and solve this idiot. Okay. So at this point, we are going to use what? Binomial theorem, two of us. Instead of using the two brackets to multiply each other, you just need 1, 2, 1, two of us. So here we are going to, okay, for the sake of viewers, let us expand it. There are some that are just going to learn as first time to expand something of this one. This is the same thing as x plus dx times x plus dx. Amen? Okay? Then x times x squared, right? X times dx plus x dx. Don't write the x squared. Please take note. Most especially Italians, because after taking series of it, you don't know what you are learning. Two of us. It's true. So this and this, they are not the same thing. Is that clear? So plus dx times x is x dx. Then plus dx times dx, dx squared. So you can now see that x squared plus, we have this to give us what? 2x dx plus dx squared. So instead of this, we are going to write y plus dy is equals to 2. This gives us what? X squared plus 2x dx plus what? Dx squared. Amen? Are you following? Okay. So far, so good. So what we need to do is y plus dy is equals to use this to open the bracket. You are going to have what? 2x squared plus 4x dx plus 2dx squared. Amen? Okay? So now, at this point, we'll subtract y from both sides. If we subtract y from both sides, it means this is, or if y crosses the sign of equality becomes what? Minus, right? So our dy is equal to 2x squared plus 4x dx plus 2dx squared minus, I told you, leave it inside a bracket. Supposing we have it in this form, 2x squared plus 1. Do you understand? So, come inside. So here, our dy is equal to, what is your y? Plus 4x dx plus 2dx squared minus what? 2x squared. So, 2x squared, right? So, at this point, you don't need a prophet to tell you. This and this will go. True or false? Okay? Students will not do us. Some of them will be putting on trousers that can oversize up. Very funny set of students. It's okay. So our dy is equal to 4x dx, amen? Plus 2 dx squared. True or false? So at this point, what we do? We divide through by dx. Divide through, yes, by dx. Amen? Amen. Okay? So far, so good. Our dy all over dx is equal to 4x dx all over dx, then plus 2 dx squared all over what? Yes. Amen? Amen. So you don't need a prophet to tell you. This and this will go. This to cancel this. Remember what? 1 dx, right? Yes, sir. Okay, so if you can see what I am saying, both in the spirit and physical, amen? Amen. Plus 2 dx. So at this point, we have to introduce what is called limits. As limits, ds tends to 0. It means our dy all over dx is equals to 4x plus 2 open bracket what? 0. So 2 times 0. So you can now see that our final answer is 1 over dx all over equals to what? 4x. Yeah. So supposing you did not get this, you have to check your working, your work. Yeah. Some persons may ask, sir, why is it that you said ds tends to 0 and you did not substitute? We have ds here, 0 here. Yeah, it's a good question. But let me just tell you that there is a difference between the y all over the x and the x. Two of us. These two things, they are not the same thing. According to the limit, as what? ds tends to what? 0. Supposing the limit says dy all over the x tends to what? 0. That is where you can substitute and take note. Is that clear? Please, it's very important. Any question? No question? Please, if you have any question, ask so that we proceed to consider. Okay, no question. So I will just do you guys good. Let me solve one example. Assuming you have 3x raised to power 3 plus x. Let's solve something like this, right? Before we consider integration. Is that clear? Me, I was thinking I've done all this. You are still copying, right? It's okay. But can I claim the first part? Yes, sir. I can claim the first part, right? Okay, so let's consider another example. Then we move to, let's look at examples like this. Let me make it square. From first principle, 3x raised to power 3 plus x squared. Okay, let's do it this way. Plus 2x, yeah, squared, right? Let's solve something like this so that if you see it in your exam, you won't be confused. Is that clear? These are the types of questions you should expect from me. From me. Is that clear? Because I won't give you something like this. This one is too simple. Come inside. It's too simple. It's for one student, not you guys are bigger boys and bigger girls. Lessons like this. If you want students that don't have words, yes, we can give them something like this. But you people are able too, so we cannot give you. It's okay. If I may ask, I won't be offended. I want to come. How to come this? That is what I'm doing. No, I don't know whether you will be offended. No, there are people like that. They don't want to show. Huh? When you are learning. Okay. Yeah. Just meet my students. They are very humble, simple. Yeah. Very intelligent. The students are very intelligent and wonderful students. It's okay. Yeah. So let's proceed, right? So let us look at questions like this. Questions like this. Okay. I know very well that this thing will help you guys. Even if you can't recall, you go back to the YouTube because it will be there. Exactly. Okay. So our y is equals to 3x raised to the power 3 plus 2x raised to the power what? 2, right? It means from our first principle, let's do it together. Is that clear so that you understand? Yes, sir. So what is the formula for first principle? It's y plus dy is equals to what? F of x plus dx. Amen? Amen. Okay. So when you come across questions like this, it means here is a function, here too is another function, true or false? So we have to compare this with this, plus compare this and this, true or false? So it means, can I clean this part? Yes. It's okay. So this implies that the first function here is, we can compare it with this f of x dx. Then 3x raised to power 3. True or false? It means our f here is what? Is 3, right? So our y plus dy is equals to 3. Open bracket. Note that our x is raised to power what? 3. So x plus dx raised to power what? 3. Amen? What we have here? Plus. The same thing applicable here. The function here is what? 2. Then it is what? Square. So our f here is what? 2, right? Then open bracket x plus dx. All the bracket raised to power what? 2. Amen? So what you need is what? Binomial theory. You have to apply your binomial theory here. Here is we just need 1, 3, 3, 1, 2 of us. Yeah. So you will do, when you get home, try and expand it. Because I'm not going to break it down again. Is that clear? So, it says for the sake of Malians, but we don't have Malians. Seriously? Yes, and the viewers too. Oh, okay, yes, for the purpose of the viewers, right? Okay. But what if I use Pascal triangle? It's okay. When we have something of this form, raised to power 3, this is the same as x plus dx times x plus dx times x plus dx. You know, this bracket into 3 places. You know, this will take our time. This is for nursery school students. What we need is 1, 3, 3, 1 from Pascal triangle. So our answer is x raised to power 3 dx 3x squared dx plus 3x dx squared then plus dx cubed. This is what we are supposed to have if we apply Pascal's theorem. But if you have the time to expand it, you still get this idiot. Amen?
Amen.
Okay? So our y plus dy is equals to 3 open bracket x cubed plus 3x squared dx. Amen? Plus 3x dx squared plus dx cubed. Amen? Then what we have here? Plus. We apply Pascal theorem. It's the same thing. We just need this one. We just need 1, 2, 1, right? True of us. We just need 1, 2, 1. Okay? So here we are going to have x squared plus x, 2x dx plus dx squared. Amen? Okay. So at this point, what we need to do here is y plus dy is equal to use this idiot to multiply out the bracket. So this one we're going to give us 3x cubed plus 9x squared dx. Amen? Then plus 9x dx squared plus 3 dx cubed, right? Then plus 2x squared plus 4x dx. Amen? Then plus 2 dx squared. True of course. Okay? So yeah, these are the types of this thing you see in your, ordinarily, if we differentiate this function, what are we supposed to have? Our dy all over the x, we are supposed to have 9x squared plus 4x. True of course. Ordinarily. Okay? So at this point, what we need to do is we have to subtract y from both sides. Amen? Okay, if we subtract y from both sides, we are going to have our dy is equal to 3x raised to the power of 3, right? Plus 9x squared dx plus 9x dx squared plus 3 dx squared, 3 dx cubed, right? Plus 2x squared plus 4x dx. Amen? Then plus 2 dx squared minus y. True or false? Okay? Can I clean this up? Okay? Yeah. So far, so good. So what we need here is, I told you that put y in the bracket, right? You can see the function. So now our dy is equal to 3x raised to the power 3 plus 9x squared to x plus 9x dx squared plus 3 dx cubed plus 2x squared plus 4x dx plus 2 d squared minus, what is your y? Your y is 3x cubed plus 2x squared, right? Okay. Yeah. Are you following? It's okay. So far so good. At this point, we have to open this bracket. True or false? So let us open this bracket. If we open this bracket, we are going to have, enjoy yourself, we are going to have 3x cubed plus 9x squared dx, then plus 9x dx squared, right? Plus 3 dx cubed and plus 2x squared plus 4x dx plus 2dx raised to the power of 2. Amen? Yeah. So far, so good. We open this bracket, we are going to have 3x raised to the power of 3 minus 2x raised to the power of 2. Amen? Okay. So far, so good. That is mathematics for you. Yeah, if you can see what I am saying mathematically. Amen? Yeah, both in the spirit and physical. Yeah. Okay. So this and this go. Amen. And this and this will go. So far, so good. Our dy is equals to 9x squared dx plus 9x dx squared plus 3dx raised to the power of 3 plus 4x dx plus 2dx squared. Amen? Amen. Okay. Any question? No question? No question? It's okay. So let us proceed. Can I take off this? Okay. Yeah. No, yeah. This and this. Take it off, right? Okay? Yeah. What are we going to? Yes, right? So if we divide 2 by x, divide 2 by dx, right? So it means our dy all over dx is equals to 9x squared dx all over dx, amen? Plus 9 all over dx plus 3dx cubed all over dx plus 4x dx all over dx, amen? Plus 2dx squared all over what? Dx. Are you following? Okay. So can I claim here? Okay. So at this point, you don't need a prophet to tell you this and this will cancel, this and this will cancel. 9x squared plus 9x dx plus 3dx squared plus 4x plus 2dx. Amen? Amen. True or false? True. Huh? True or false? True. No. After taking series of which, if they say true, that is what I'm saying now. If they say true, your brain will be telling you to say false, 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 false. Amen? It's okay. So, let us proceed. Let us proceed. Somebody is asking me how did I expand the y value? I don't know. Which of the y values? Is it, enjoy yourself. Is it, okay, is it this one? Is it this one the person is talking about? Yes, all is square. I thought I expanded something like this now, two of us. Yeah. So please go back to the beginning of the video, you will see it. Okay. Yeah. So far, so good. At this point, we are going to introduce what? As the x tends to what? 0, right? Okay. So what we need here is our dy all over the x is equals to 9x squared plus 9x squared plus 4x plus 0, right? So, are you seeing what I am saying? So you can now see that we arrive at the expected answer, true or false? Because Whole of this we're going to give you 0. So our dy all over dx is equals to 9x squared plus 4x. This is the final answer. Amen? Amen. Okay, so just copy, then immediately you are done. Okay, the person has gotten it. Immediately you are done, we proceed to integration, right? Yes, sir. Okay. Yeah, in integration, we have to take note of this. Sin x dx will definitely give us what? Minus cos x plus the constant. Cos x dx will definitely give us sin x plus the constant, right? Okay, if we have sec square x dx, we are going to have tan x plus a constant. Then if we have cosec square x dx, we are going to have minus cos x plus a constant. Take note. Amen? Amen. Okay? Then if we have dx all over 1 integral dx all over 1 plus x squared, this is equals to tan inverse of x plus the constant. Yeah. Then if we have integral dx all over, take note, square root of 1 minus x squared, take x squared, yes. This we are going to have sine inverse of x plus k. Take note, come inside. Take note, you can write those things down. Write it down. Just write it down. Yeah. Okay, let's proceed, right? Let's proceed further. Can I clean this other part? Yes, sir. Yeah? Yes, sir. This up, I want to clean. Yeah. Okay. Well, we have cosec x plus x dx. We are going to have minus cosec x plus constant. sec x times x dx. I can do this, right? Integral sec x times x dx is equals to sec x plus where we have integral ax plus b all in dx is this is the same thing as ax plus b raised to the class of n plus 1 all over n plus 1 times a plus the constant. Take note of this because we'll be making use of all these things. Very important. Amen? Amen. Okay. Then, yeah. Integral sine over ax plus b dx. This is equals to minus 1 over a cos open bracket ax plus b plus the constant. Likewise, if we have integral cos ax plus b dx is equals to 1 over a sine open bracket ax plus b plus k. Take note of all these things because they are very, very important. Same time, when we have integral exponential ax dx, this is the same thing as exponential ax all over a plus constant, and when we have integral dx all over a squared plus x squared. This is the same thing as yeah. 1 over 8 and 8 inverse of x over 8 plus constant. No, I'm mistaken. Yeah. This is a. So take note of all this because anytime soon you're making use of them. Then here what is the problem? What is the problem? You are part of us. On this side. Okay. If we have x squared ax plus b dx, this is equals to 1 over a times ax plus b plus k. Are you done with this part? Yes, sir. Please take note of all these things because anytime you will be using them. Then cosec square integral cosec square ax plus b x. This is equal to minus 1 all over a cot open bracket ax plus b plus c. Okay. Take note of this. Then if we have integral dx all over square root of 1 minus x square, right? Oh, sorry. This is a square minus x square, which is going to give us tan inverse x all over a plus a. Yeah. Okay. That is that. So take note of all those things. So let's begin to. Yeah. Huh? Tan. Integral of tan. If you integrate sec square what? Theta. If you integrate sec square theta, you are going to have what? Tan, right? It means if you differentiate tan, you are supposed to have sec square. So, I have integrate tan. It's okay. Yeah, let's move further to consider some examples here. Example. Evaluate integral. You know, I told you these are what? Indefinite integrals. True or false? All over x squared. Yeah. X squared dx. Okay. So solution, our integral x squared plus 1 all over x squared dx. Let's solve this together. If assuming, can I clean this part?
Yes, sir.
This one. Up. Up.
Yes, sir.
If we have a plus b all over a squared, you know that we can still rewrite it in this form. A squared plus b all over a squared. Then this is going to give us 1 all over a plus b all over what? A squared. True or false?
Yes, sir.
Yes, sir. So if we have function of this form, we can rewrite this idiot in this form. This is the same thing as integral of x squared all over x squared plus 1 all over what? X squared. True or false? Yes, isn't it? Then this is the same thing as you know, I told you that when we have something on this form, assuming we have integral a plus b dx, we can rewrite this integral in this form. Integral a dx plus integral b dx. True or false? Okay? So if you can see what I am seeing here, you don't need a prophet to tell you. Amen? Amen. Okay? So, yeah, before we do that, let us, this 1 plus 1 all over x squared dx, isn't it? Then this is equals to integral 1 dx plus integral 1 all over x squared dx. Amen? Okay. You don't understand? How? X squared divide x squared. 1. You have 1 now. Look at the 1 here. Amen? What are you taking, my friend? Then plus 1 all over x squared. I said, if we have something like this, we can still rewrite it in this form now. This and this, they are almost the same thing now. True or false? Okay? So far, so good. So, go back to your indices. If you can recall, indices, when we have 1 all over a, this is the same thing as a raised to the power minus 1. True or false? I want to do something. So what if you have 1 all over a raised to the power 2? This is the same thing as a raised to the power 2 minus what? Okay, so if you can see what I'm saying, remember that 1 times the x is the same thing as the x. True or false? So this is the same thing as integral the x plus integral x raised to the power of minus 2 dx. Amen? Amen. Okay. So if we integrate this idiot, we are going to have, if you integrate the x, you are supposed to have x. So here you are going to have x. Then here we are going to have minus x raised to the power of minus 2 plus 1 all over minus 2 plus 1, right? But it's not necessary. We are going to have minus what? 1. Minus 1, isn't it? Plus k. Then the final answer will now be x minus 1 all over x plus k. Any question, please? If you have any question, ask.
Yes, sir. Yes, sir. How do you get this x raised to
X raised to the power of minus 1. We are integrating now. When you are integrating, this is your n.
Yes.
Look at it now. If you are asked to integrate this dx, the formula is what? Ax raised to the power of n plus 1 all over n plus 1 plus a constant. True or false? So your n here is minus 2 plus 1. Amen? Minus 2 plus 1, just like you are owing 2 naira. Minus means you are owing. So you are owing 2 naira, true or false? The plus, you have it. So if you use, you have plus 1, it means you have 1. So if you use 1 to go and pay your 2 naira debt, how much will be left? 1 naira, right? Are you owing or you are not owing? For the fact that you are owing, it will be minus 1. Is that clear? It's okay. So can we proceed? Let's proceed. So this is how you are going to approach this type of question. Is that clear? So let's consider another example. Integrate 2x plus sine x. Evaluate another example. Evaluate integral 2x plus sine x dx. Okay? Yeah. So when we write solution, right? Our integral 2x plus sine x dx is equals to, this is the same thing as integral 2x dx. True or false? True or false? You people should listen though. Then what we have here plus integral Sin x dx. Amen? So if we integrate 2x dx, what are you supposed to have? You are going to have 2x raised to the power 1 plus 1 all over 1 plus 1. Then, if you integrate sin x dx, you are supposed to have minus cos x plus a constant. Then this is going to give us 2x squared all over 2 because 1 plus 1 is 2. Then minus cos x plus k. Amen? This and this will cancel. True or false? Then this is equal to x squared minus cos x plus k. Amen? Amen. Any question? But I'm not going to give you guys this simple. These questions are too simple. It's for anyone students. These are very simple questions. You will see the ones. If the life exam is 30 minutes. That is why they said always study. Here you are, and you are not supposed to do any other thing. Just face your studies. No, I told you that Nigeria is a scalar quantity. It has magnitude but no direction. I'm telling you the truth. Yeah. It is only in Nigeria that, after you graduating, engineers like you, they will send you to go and serve in the bank. What will you be that? Or they will send you to hospital, clinic. No, me, I'm talking of NYC. It's okay, let's learn. So at least with integration and differentiation, calculus will be able to change the mentality of Nigeria. No, that is the truth. That is the truth. See, if you go to China, they are doing practical things. Yes. They are doing practical things. Amen. Okay, let's integrate this. Can I play here? Another example. Let's consider another example. Evaluate 4 minus 3 x all over 7 plus 6x squared dx. Yeah. Okay. Let's move further to consider this. See, let me tell you, the reason why we are finding it difficult. Let me just be sincere. Somebody, they born last year, his brain is more sharper than my own. Let's be frank. Yeah, let me prove it. Let me prove it. Let me tell you. You know why Nigeria cannot progress? Nigeria, go to your state governors those days. Go to assembly those days, set of what? Men. Their belief is they struggle to make it. So those that are coming behind them, you have to approach that same method to make it. So it will be difficult for them to change. That's just it. If you as a young guy, okay, if I can remember, the former EFCC boss, he was saying something that, is it 18 years boy, was able to open his laptop. Yeah. And he was asking me, he said he want to enter his account, how much? He was surprised. But those sets of people, they could not do all those things. That is the knowledge I'm talking about. That is the knowledge. That is the knowledge. We're in modern life. But those set of people, they don't want us or want you. Because they believe, you will see a father saying that before he will die, he will sell all his property so that his children will not work. That is what I'm saying. No, that is what I'm saying. But in advanced countries, they plan ahead of the future. Those people that will come, let them benefit. Even if they are no more. Even if they are no more. That is why they are growing. If you have any idea, they will call you, come, let's work together. So that at least our nation will succeed. But here, immediately you have one idea, okay? Now this one get the idea, or rather they will just cut you off. Even if you call, they won't pick your call. So that is the mentality. African mentality. Very poor mentality. So that is why some of us that have opportunity, we travel out. Not only China that are doing all those things they are doing. If you go very deep, Nigerians are there involved. Yes. Nigerians are involved. But they don't want to, the government don't want to give such people privilege. If this person empowered him, they want to talk about history. You work with so person, two of us. So if supposing that state was PDP that was ruling, then all of a sudden another party took over. Because of that, they want to what? Do sentiments. Yeah. So either to close your industry or turn into what? Square one. Two of us. Because you were with PDP government. This is not PDP, this is so government. So how can we grow? We cannot. Because of our black mentality. Very dirty mentality. Sorry to say that. I'm telling you the truth. Yeah. Let's learn calculus so that we will change our minds in mentality. It's okay. So let us. Okay. So this is the same thing as integral 4dx, two of us, minus integral 3x all over 7 dx, right? Plus integral 6x squared dx, right? Okay, this is constant, two of us. We can still write it in this way, 4 integral dx minus 3 all over 7 integral x dx, amen? Okay, plus, the question is in order. Yeah, it's in order. then plus 6 integral x squared dx. Amen?
Amen.
Okay? So far, so good. This is equals to, if we integrate dx, what is supposed to have? X. This is to multiply this constant. 4x, right? Then minus, if we integrate x dx, we are supposed to have x squared all over what? 2. True or false? So we are going to have 3x squared all over 7 times what? 2, right? Then plus, if you integrate x squared, what is supposed to have? X squared.
It's x cubed.
X cubed all over 3, right? Times 6. 6x raised to the power 3 all over 3 plus a constant. Amen?
Amen.
Okay? So if you can see what I am saying, this is the same thing as 4x minus x raised to the power 2 all over 14 plus 6 and this 3x raised to the power of what? 3 plus what? 8. This is the final answer. Any question, please? Do you have any question? Huh? Where?
How do you integrate that x squared?
This x squared. X squared dx. We apply the formula now. This is your n here is what? So 2 plus 1 all over 2 plus 1 now. No noise, please. Stop making noise. Okay. Let us consider. Okay, I want you guys to consider this. Another example. Evaluate integral 2x cubed minus 3x all over 4x dx. Who has finished? Aya, solve this. Solve this. Solve this. Solve it. Give space and write. Give space and write. You are economizing your notes. Write boldly. You are jamming your handwriting. Give space and write. Who has gotten it? Nobody?
Almost.
What you need to do, you just need to divide it. Divide 4. No noise. 2x raised to the power of 3 all over 4x minus 3x all over 4x. This is what you are supposed to do. Then this and this will go to give us what? X raised to the power 2 all over 2. True or false? Then minus this and this will go 3 all over 4. Yes. True or false? Then this is the same thing as x squared all over 2 dx minus integral 3 all over 4 dx. Amen?
Amen.
Amen. Okay, yeah. So if you can see what I am saying, what is constant here? Something is constant here. No. Thank you. 1 over 2 is constant. So we can factor it out. Integral x squared dx. What is constant here? 3 over 4. Integral what? Dx, right? So if you integrate this, what are you supposed to have? You are supposed to have 1 over 4, 2 and x raised to the power of 3 all over 3 minus 3x all over 4 plus k, isn't it? So this is equal to x raised to the power 3 all over 6 minus 3x all over what? 4 plus k. So, yeah. Any question? You got it? No noise. Please. No noise. Okay, let's consider examples. Integrate, evaluate integral 1 plus t, all is equal to t. Amen? Amen. Yeah. It's simple as ABC. What you need to do is you have to expand this 1 plus t all is square t, right? It means we are integrating with respect to t, true or false. So this is 1 plus t all is square is the same as 1 plus t times 1 plus what? T, right? So what are we supposed to have? We are supposed to have 1 plus 2t plus t squared, right? Yeah. So here is integral 1 plus 2t plus t squared over t. Then this is the same thing as integral dt plus integral what? 2t dt and plus integral t squared dt. True or false? Huh?
True, sir.
Amen?
Amen.
Okay. So integrate this, we are going to have t plus 2t squared plus t all over 2, sorry, 3 all over plus d, right? True or false? True. So it is either this and this will go, this is t plus t squared plus t raised to the power of 3 all over 3 plus what? B. This is the answer. Any question? Do you have any question? If you have any question, please ask. It's very important. What is the problem? You are asking a question. Can I clean this side?
Yes, sir. But not all.
Okay. Evaluate 3x plus 2 all over. Another example. Evaluate integral 3x plus 2 all over square root of 1 minus x squared Yes. Yeah. Amen. Okay. So at least the integration, this is the first integration we copy. You know, I told you that we'll be making use of them, so you should know them. Is that clear? When you look at this, you don't need a prophet to tell you. This one will give you what? Tan inverse of what? X, right? Is this sine inverse? Sorry, sine inverse of what? X, right? Okay. So if you know all those things, it's simple as ABC. So now what we need to do, we write solution, right? This is the same thing as integral 3x. Is it 3x squared? Sorry. It is 3x, right? 3x dx plus integral 2 all over 1 minus x squared dx, right? Okay. So if we integrate this, we are going to have 3x squared all over 2 plus yeah. Is it minus 2? It's 2 now. 2 times sine inverse of what? X, right? Plus k. True or false? Yeah. Because this is the same thing as, I know you may ask, why we have something of this form. This is the same thing as 2 times 1 all over 1 minus x squared. True or false? So take note. So whatever you differentiate from whatever you get, you need to multiply these two. That is why you are saying 2 sine inverse x. Exactly, plus the constant. Okay? So let's consider more examples. Let's consider more examples, right? Another one is evaluate integral minus 5 all over 9 fourth root of 3 raised to power 3 integral. Amen? Yes. Right. Yeah. So let's consider this. Is that clear? You can now see that calculus is not that difficult. Is calculus difficult? Yes. Calculus is not difficult. Minus 5 all over 9 fourth root 3. This is the same thing as, let us go back to our indices. When we have fourth root of 3, this is the same as 3 raised to the power 1 over 4, right? Okay. Then, what if we have fourth root of 3 raised to the power 3, known as 3 raised to the power 3 all over 1 all over what? 4. Is that clear? It's okay. So it means this is 3 raised to the power of 3 all over 1. 4, right?
Yes, sir.
So if you agree with me, the integral will now be minus 5 all over 9 t raised to the power of 3 all over 4 t, right? True or false? Okay. So far, so good. Okay. So what we need to do, what is this in here? The constant here. Minus 5 all over 9 integral 1 all over 3 raised to the power of 3 all over 4 dt, right? So we can still rewrite this idiot in this form. Yeah. Integral t raised to the power of minus 3 all over 4 dt, right? So let us integrate. If we integrate, we are going to have minus 5 times integral minus 3 all over 4 plus what? 1 all over what? Minus 3 all over 4 plus 1. Isn't it? Plus k. True or false? So let's look for the LCM. Here is minus 5 all over 9 times 3 raised to the power of what?
1 over 4.
1 all over 4. All over what? 1 all over what? 4, right? 1 all over 4. Plus k, right? Plus k. True or false? Then my right. Yeah. I'm right, because here will be 3 plus 4 all over 4. 1 all over 4. Yeah. Okay. Yeah. You can stop here, or if you can see what we are seeing. Well, here will be what? Minus 20 t raised to the power of 1 all over 4 all over 9. Plus what? K. K. True or false? If t divide 1 all over 4, this is the same as t divides 1 all over 4, then our t, we convert this to what? Times what? 4 all over what? 1. True or false? So this is the same as 40. So 40 times minus 5. Huh? It's minus 20 now. True or false? Okay. Then let's proceed from that. as it is, it will be difficult for you to integrate this function. Listen. Listen. So we have to think. We have to think. So, can I take on this part? So, integral the x 1 over x squared plus x plus 1. Now, I want to do something. Please listen. Since we cannot integrate this function as it is, it means our x squared plus x plus 1 is the same thing as x plus 1 all over 2 all is square plus square root of 3 all over 2 all is square. Amen. So as it is, we can now what? Integrate it. So we have to. Yeah. Okay. Listen. I know you people are blind mathematically. You are blind mathematically. That is what I mean. Okay, now, if you are doubting, if this is the same as this, let us justify it now, two of us. How? We have to expand this bracket. Can I play this part?
Yes, sir.
Let me take everything here. Let's look at it. If we have x plus 1 all over 2 all is square, amen?
Amen.
This is the same thing as x plus 1 all over 2 times x plus 1 all over 2. Two of us. X times x. X times plus x all over 2. This times this plus x all over 2. Two of us. Then this times this 1 all over 4. Two of us. You agree with me?
Yes, sir.
Okay. So here is x squared, this one plus this. We are going to have 2x all over 2 plus 1 all over 4. This and this we cancel. Amen?
Amen.
Then we are going to have x squared plus x plus 1 all over 4. Then here we have we have square root of 3 all over 2 all in square. This is the same thing as square root of 3 all over 2 times square root of 3 all over 2. Then this times this 9, right? Is 3. Two of us. 3, 2 times 2. So what are we going to write here? Here we are going to have since we have x squared plus x plus 1 all over 4, right? Then plus 3 all over 4. Take the answer. 4, right? 4 divide 4. 1. So you can now see that x squared plus x plus 1. It means this is the same thing as this. That is your special.
So, how now from here?
That is why you have to think. You have to think. Yeah. You have to think. Yes. Thank you. So now, instead of this, we can substitute in this. Two of us. So the integral. Okay, the integral will now be equal to integral d all over x plus 1 all over 2 all in what? Square plus all over 2 all in square. Yeah. Let's go back to our integration. Those properties that you write down. Thank you. inverse, because tan inverse is when we have a squared plus what? X squared. True or false? This is going to give you what? 1 over a tan inverse, right?
Yes, sir.
Of x all over what? A plus constant. True or false? Amen? Do you understand? No, there is no problem. Yeah. You have to think like a mathematician. Okay. So look at it. So if we are to integrate this, it means we are going to have 1 all over this. True or false? Integral yes all over x plus 1 all over 2 all square plus sorry 3 all over 2 all square. So it means we are going to have what? We are going to have 1 all over square root of 2 tan inverse of x plus 1 all over 2 then all over 3 all over 2 plus the constant k. True or false? Then we can see move further to write it in this one. This is 2 all over 3 tan inverse of 2x tan inverse of 2x plus 1 all over. True or false? Yeah. I have a question.
I thought that from the question, x plus 1 over 2 which power 2 must be equal.
Who's your ex now?
So I thought the first one should be from the special integration. You state 1 over 8 tan inverse.
What do I say?
That's
No.
See that what you did was this first function here is x, and the second function is a. So can you just write for so that yes.
You can indicate it.
I think that's the question.
The question is asking. You can indicate it now.
X and the second one is you just substitute now.
Oh, okay. To make it more simpler, listen, my friend. Listen. Where are you going? Go. You can write it in this form. Root 3 all over 2. Are you okay now? It's the same thing. Is that clear? It's okay. So let's consider you are asked to evaluate integral 7 check square 40 to 2, what are you supposed to have? Hmm?
1/8.
Is that? No, this is 4 now. It's not 3. The other day I told you that if you are to integrate from ax dx, you use this constant to divide what is here after integration. So what you need to do, this one will give us 1 all over a sine ax plus what? A constant. So if assuming you have cos 4x dx, what are you supposed to have? Huh? Yes, 1 over 4 sine 4x plus what? A constant. So if you have something like this, what are you supposed to have? 7 all over what? 4, right? 7 all over 4 times what? 40 plus what? Is it difficult? No. Is it difficult? No. It is not.
No.
You are still writing.
Okay.
Okay. That is all now. So if you are asked to integrate